Hey, everybody. So we are getting into the Chapter 7 test review on DeltaMath. As always, I'm going to be going over the class examples. So kind of stick with me as I go through those. After I do a class example, it's not a bad idea to then try out some problems on your own and then, bounce back and forth. Okay, so let's just jump into it. The first thing is getting to using the Pythagorean theorem. Right. By the way, on this, make sure you're showing work on a separate sheet of paper on any problems that require work like this one. All right. So quick example, or I guess quick reminder on the Pythagorean theorem. All right. It's what we use to find the missing side of a right triangle. All right. And whenever we had the two other sides, okay, and that's exactly the case with this problem. C squared equals A squared plus B squared. That's the way I teach it. So let's go ahead and write that out. All right, so C squared equals A squared plus B squared. All right, big thing to always remember, and the reason why I start with C in the formula is because that is always the hypotenuse of your right triangle, which you can always find opposite that right angle. So it looks like 4 needs to be plugged in for C. Okay, A and B are the other two short sides. Okay, one of them is going to be 3. The other one I'm going to call X. I like to use X as my variable. Okay, so 3 for A. And I'm plugging in X for B. All right, so from here, let's see how quick we can do this. 4 squared is going to give me a 16. 3 squared is 9 plus X squared. Okay, now I can start solving for X. First thing is getting rid of 9 by subtracting. Right, looks like we're getting a 7 on the left. And we have X squared on the right. Okay, last step, remember the opposite of squaring. To undo it, we have to do square rooting, all right? And to both sides. So typing in the square root of 7. If you don't know how to use your calculator on this, please talk to me. That's a big thing. Okay, here's another big thing. DeltaMath often wants you to round a certain way. Always double check your directions before you enter your answer. This one wants us to round to the tenths, okay, which is what we're used to doing. All right, so in your calculator, hopefully you're getting a 2.64. All right, tenths is just one decimal place. So the only question is, does this stay a 6 or does it round up to a 7? And that's all dependent on this number next to it, right? If this was a 5 or more, we would round this to a 7. But since it's not, 2.6 is our answer. Okay, so again, I recommend pausing the video, trying out some of those Pythagorean theorem problems, and then coming back. All right, so from here, it gets into solving for interior angles of triangles. I don't have an example for these because I think you should be able to do them. These are the problems where all you need to remember is that the 3 angles of a triangle add up to 180. All right, so you'll do X plus 111 plus 27. Your example is going to look different than this, but you'll add those together, set it equal to 180, and go from there. Okay, and that's what the next couple sections are about. All right, the next one I want to look at here, though, is properties of isosceles triangles. Okay, so this one is describing an isosceles triangle, and it wants us to find a missing angle. Okay, quick reminder on that. Okay, when we have an isosceles triangle like this, the idea is that the two congruent sides, opposite those sides, we have 2 congruent angles, the base angles. All right, so let's start by drawing this triangle that they're describing. That's a big thing. They haven't drawn it. Drawing it's going to help a lot. Okay, so I'm just going to draw a generic looking isosceles triangle. Okay, and they're calling it WXY. So WXY. Okay, and they're saying that XY, this side, is congruent to WX, this side. Okay, they're telling us the measure of angle W is 61, and they're wanting us to find the measure of angle X. Okay, so first things first, since these sides are congruent, we know that the angles opposite them are also congruent. So we know that this angle is congruent to this one. If this is 61, we know this is 61. Okay, and if that's what they were asking for, if they were asking just angle Y, we'd be done. It'd be 61, right? But they want us to actually go a step further and find this top angle called the vertex angle. Okay, but we can just do the 180 thing, right? We know if we take 180, subtract the 2 angles of a triangle, we're going to get the missing angle. So let's see what happens. Okay, I'm getting 58. Okay, so that is angle X right there, and that's what you can enter for your answer. All right, let's go ahead and keep going. So let's see, moving along from here. Next thing, exterior angles, triangles. Go ahead and click on this class example. All right, so this one is giving us the triangle. That's nice. And it's dealing with an exterior angle. So quick reminder on this. Okay, this is using this little formula here. Our exterior angle is equal to these two interior angles added together. Okay, so let's use that formula on this. Okay, on this problem, they're giving us the exterior angle, right? So that's the first thing we're going to plug into our formula. So 115. And we know that's equal to these two interior angles added together. One of them is X, and one of them is a right angle. Remember, our right angles are always 90 degrees. Okay, so there's our formula, and really simple, right? Just one-step equation. We'll get rid of 90. And 115 minus 90 gives me 25. Okay, so yeah, again, go ahead and enter that answer, and we'll keep moving. All right, moving along. Let's see, next one, exterior triangle angles. Go ahead and click on this example here. Okay, so this one throws quite a bit at us. It's describing a triangle. So before we get too stressed, let's draw the triangle that they're talking about. So we got triangle PQR. So let's go ahead and draw that. Okay, I'm just drawing a generic triangle. This is PQR. Okay, here's what they're saying. Segment PR is extended through point R to point S. Okay, that's kind of weird, but what they're telling me is that segment R is continuing outside the triangle and it's going through a point S. Okay, so that's what we got. I'm going to scoot R over. Sorry. Okay, and let's see what we got. So the values. The measure of angle PQR is 3x plus 12. So let's find PQR. Remember, that starts at P, goes around Q to R. They're talking about this angle. Okay, so this is the 3x plus 12. I'm going to write it on the outside since I don't have a lot of room, but we're talking about this angle. Okay, next thing, angle RPQ. That starts at R, goes around P to Q. So this angle is 3x minus 11. Okay, and then last thing, angle QRS is 8x minus 9, starting at Q, going around R to S. That's this exterior angle right here. They're saying is 8x minus 9. Okay, and ultimately they want us to find the value of X. Always double check, by the way, if they want you to find X or if they want you to plug it back in. DeltaMath will switch it ever so often. All right, so now that we have it drawn out, hopefully we realize what's going on. Again, we're using the exterior angle theorem here. That angle on the outside is equal to those two angles on the inside added together. And so let's do just that. So the angle on the outside, 8x minus 9, equals these two interior angles added together, 3x plus 12 plus 3x minus 11. I'm going to give myself some more room, sorry. So 3x minus 11. Okay, and then it's just a matter of solving this equation. So let's do it. So on the left, I noticed no like terms, okay? But on the right, I do. I have a 3x and a 3x and some other numbers. Let's just work left to right, though. Let's bring down the 8x minus 9. Okay, on the right, let's combine these. 3x and a 3x is a 6x. 12 minus 11 gives me positive 1. Careful with that sort of stuff. Okay, from here, now I have variables on both sides. I'm going to get them to the same side. I'm going to choose to move the 6x because I can see that's going to give me a positive number. Okay, so I got a 2x on the left, bringing down the minus 9. On the right, I got that positive 1. Okay, from here, I just have two-step equation. So add 9 and divide by the 2. Okay, when we divide by 2, looks like we're going to get x equals 5. Another thing, when you're using DeltaMath, if you ever get a decimal and your directions are not telling you how to round that decimal, it's likely that you shouldn't be getting one. Okay, so just a thing, if you did your math wrong, I got like a 5.2, they're not telling me how to round, I should probably double check my work. Okay, but and over here, when you enter your answer, you can just put 5. You don't need to put x equals 5. Okay, so yeah, I would recommend pausing that and trying the other problem. If you have any questions on these are weird ones, let me know. Okay, moving along. Next thing we got is the triangle inequality theorem. These are nice and easy. So let me remind you guys on this. Okay, so the idea on the triangle inequality problems is basically if we add the two short sides together, that needs to be greater than the longest side. Okay, so this is really the only one that we care about when we go to do these problems. And you guys take a look on the directions. Okay, they're really important. This is asking which of the following sets of numbers could represent the 3 sides of a triangle. Okay, it's saying could represent. Look out. Some of these problems will randomly throw which of these numbers could not represent the 3 sides of a triangle. Make sure you always read the directions on DeltaMath. Okay, so which of these could represent a triangle? Which ones work? Well, let's go through and see when we add together the two small sides, it should be greater than the third. Okay, so 6 plus 8 is giving me 14. Is 14 greater than 14? No, it's not. This one doesn't work. Okay, moving on here. 13 plus 20 gives me 33. Is 33 greater than 34? Nope. Next one. 11 plus 14 gives me 25. Is 25 greater than 22? Yeah. Okay, but I would always double check this last one. 13 plus 20 gives me, 33? Is that greater than 35? Nope. Okay, so there it is. That's your one. Okay, so yeah, don't miss these problems. Double check the directions though and make sure you understand what exactly they're asking for. All right, moving along from here. Scroll down. I'm going to look at the interior angles of polygons. Okay, so yeah, this gets into using this little formula right here, n minus 2 times 180 to figure out what do the interior angles of a polygon add to. Okay, on this problem, they're asking us what is the sum of the interior angles of a 16gon, meaning it has 16 sides. Okay, and all we have to do is plug that into our formula. Okay, so let's write out the formula first. N minus 2 times 180. Okay, with this thing has 16 sides, so 16 minus 2 times 180. 16 minus 2 is 14, and 14 times 180 gives me 2,520. And that's your answer. Okay, so if you know the formula, these should be fairly straightforward problems. Okay, if you want to try some out, go ahead and pause the video. All right, moving along, let's see. Next one, interior angles of polygons, level 2. Okay, so look at this one. It's saying how many sides does a polygon have if the sum of the interior angles is 540? So these are the reverse opposite problems. All right, when we go to do these, we're still using our formula, the n minus 2 times 180. Okay, but we know what that equals. It's saying that those add up to 540. Okay, and it's just a matter of now solving this for n, and we'll know the number of sides. Okay, when we go to do this solving, you guys might remember we need to deal with this 180 that's outside of the parentheses first. It's being multiplied, so we divide. Okay, those are gone. I got n minus 2 equals 540 divided by 180. Looks like I'm getting a 3 over here. And then solving for n, add 2. Don't forget to add the 2. Sometimes people will get the 3 and they'll stop and say their answer is 3. Looks like n equals 5. Okay, and that is the number of sides. This thing has 5 sides. All right, we're getting close here. Let's see. I think I have one more problem here. Exterior angles of polygons. Go ahead and click on it. Is it gonna load? Sometimes DeltaMath does this. If that ever does, go ahead and just refresh it. Usually refreshing and then clicking on it again does the trick. Usually. Okay, there it is. Okay, so this is saying the measures of the exterior angles of a heptagon are all of that. Find the measure of the smallest exterior angle. Okay, first thing to remember when we're dealing with exterior angles, okay, the sum of the exterior angles of any polygon is 360. It doesn't matter that this thing is a heptagon. All it matters is that we know that all of these exterior angles add to 360, and that's the first thing. Let's go ahead and add them together. Okay, so let's see, I'm going to do here. So x plus 3x plus 4x plus 5x. What am I doing with these commas? Plus 5x plus 6x plus 8x plus 9x. Okay, so this is a heptagon, by the way, which means there's 7 sides and 7 angles. Make sure you actually have the correct number of terms. We do have 7 things being added together. Those all add to 360. Okay, so let's go ahead and solve for x. It looks like we have a bunch of like terms, right? These are all x's. We can combine all of these together. All right, so just be careful with this. Remember, this is a 1x, so 1 plus 3 plus 4 plus 5 plus 6 plus 8 plus 9. All of those x's added together gives me a 36x equals 360. Okay, and those are nice numbers, right? We can divide by 360, and it's going to go into that 10 times. Okay, be careful. Some of these problems will ask you to just find x. If that was a case on this, we'd be done. This problem doesn't want just x. It wants us to find the measure of the smallest interior angle. Okay, and that means plugging it back into our smallest angle. Just so happens that our smallest angle is x. So when we plug this thing back in, the measure of the smallest angle is going to be 10 degrees. Okay, so it was easy math when we plugged back in, but it might not always be as simple as just plugging it into an x. Okay, but yeah, there it is. You can go ahead and just put 10. Alrighty, cool. So there's the review. Go ahead and try out the problems you haven't got to. Ask me questions, and you'll be just fine on the test.